I'll see if I can wake you up a little bit more here. So I think if I refresh this is it's vibrating a little bit more, and then after a while it's slowing down. So the name of this talk is Full Stack Scala, and as you mentioned, this will be about developing front-end applications using Scala all the way. So we're going to use Scala JS on the front end, and we're going to use Scala on the back end. Yeah, so let's get started. But first, a small digression, a small quiz maybe first. Which flag is this? Norway. And today it's the Norwegian National Day. So I'm not normally very nationalistic, etc. But I just wanted to take this opportunity to say gratulerer med dagen to all the fellow Norwegians here. So this is when you should be putting up your Norwegian flags, and we can sing the national hymn afterwards, okay? For those who want to stay behind. Anyway, so let's get to the important part. So back in the days, your Scala code used to compile to JVM bytecode, okay? Slowly, right? But it still managed to create some JVM bytecode in the end. Today this has changed a little bit. So today you have multiple backends. So the Scala code can compile to JVM bytecode. It can compile to JavaScript code, and since some time also to native code using Scala Native. And this is obviously very nice and very exciting. This gives us a whole new kinds of opportunities. I'm going to focus in this talk about the two first ones. I think there's been some talks already about doing Scala Native, which is also very exciting. I'm going to start with this small slide here. So here you can see the sea and the sky. And there's two islands, and on these two islands there are some people. Okay, so far so good. We can add a small sun and some palms. Now, what I wanted to say is that if these people want to collaborate to do something, they're living far away from anyone else, so, well, they kind of have to collaborate to make something. I don't know, maybe an airport, maybe a boat, maybe something. They have to find a way to work together. And this is obviously more difficult if they are not speaking the same language. So this is not an impossible challenge, even if people are speaking different languages. We can always learn new languages, but things are much easier when we can just do things in a language that we are familiar with, in particular, or native tongue. Okay, so I've been struggling with this for many years. I've been trying to learn French for 10 years now, and I'm still struggling a lot. And yes, it's not easy. English is a little bit easier. You should start early. So I think we can take this. So who is guessing where I'm getting to with this slide? Yes, very good. Okay, so let's imagine that this is the front end and this is the back end. It's much easier if we have the same language on both ends, right? If you don't have to think so much. And talking about thinking, I have a small slide with a big brain on it, and I'm going to talk about context switching. So context switching is what is happening when we're changing from one language to another language. This would also change when we're going from coding front-end code to back-end code, even if they are in the same language, but the context switch is going to be smaller. I read on Wikipedia that doing a lot of context switching, it can reduce the speed or your productivity by up to 40%. Okay, so this is some numbers to think about for those working on a lot of projects at the same time. In addition to this, you will be making more errors. Okay, at least I do. And the third point is that whenever we write some code, at least I do this, I kind of try to be the compiler. I try to understand what the compiler is doing. I'm trying to guess what the compiler is going to say. Is the compiler going to figure out what I intended to say or not? So if we have both JavaScript and Scala, we will be doing a lot of compilation in our head. And in JavaScript you have to do more because we have no guarantees from the compiler, right? So that's what I wanted to do. There are benefits of using only one language. So let's get started. I have created this small SPT git array template. You can use this one just by typing spt new tbje and fullstack.g8. This will download all you need for getting started with full stack Scala development. You will get, for the backend, HTTP. Sorry. You will get AutoWire. So AutoWire will allow you to do Typesafe RPC. Okay, so this is really nice. It gives you a really nice layer between the front end and the back end, connecting these two. AutoWire also needs some kind of serialization mechanism, and I've chosen BooPickle for this example. So there are other options as well. You could do uPickle. BooPickle is a binary format, so that's quite nice. Finally, we have Scala tags that is also added to this project, which allows us to write HTML and CSS in JavaScript. So let's look at what we got when we download this git array templates. We'll get a couple of directories here. So we have the familiar build SPT file. You will see a target, and then in addition to this, you will have three source folders. So the JS one, the JVM one, and the shared one. Okay. If you look at build SPT, you will see that we will have 4 projects. Okay, 4 or 5, depending on how we define we see it. So you will have the client project, you will have the server project, you will have a shared JavaScript project, and you will have a shared JVM project. The client project is going to depend on shared JS. The server project is going to depend on shared.jvm. Okay, I think I have some arrows here. So all the sources that we put in the JS folder will be compiled to JavaScript. All the sources we put in the in the JVM will be compiled to JVM bytecode. And for the shared folder, it will be compiled to both. Okay, so this is quite cool. Now, I think I forgot one slide. I had some git merging going on right before this, so never do this. But how do you get started? Well, we type spt restart. What is happening here? I don't know. Okay, so this takes some time. The first time, it always takes some time. We're going to download the internet. I don't have to do this, but this is what you will see. Oh, and it's very small. It's very tiny. Let's blow it up a little bit, and you will see the timestamp. Okay, so this timestamp comes from the server. So the Scala JS application, it's been doing an RPC call to the server and is fetching this timestamp back. So let's have a look at it. So this is the client part. Is it big enough? Do you want to blow it up a little bit more in the back? It's good. Okay, so we see the client. We have this main method that gives us an entry point. This part here is just for my presentation. So all my presentation is actually written in Scala JS, which was a little bit challenging compared to doing a PowerPoint, but still it was quite fun. So here we see this wire thing, and it's calling get from server. It's doing a call on this, and when this call is completed, you will either have a success or a failure. And in the success, you will have this M here, which is going to be the message. So let's have a look at the API. So the API is what we are using. And this one is defined in the shared folder. So this is compiled both to JavaScript and to JVM bytecode. So you recall this, get from server, and it's returning my type. So what is my type? Let's look it up. My type is just a case class with a message and a Java util date inside of it. We see here that to be able to pickle and unpickle this, since it's a Java class, we have to create a custom pickler for it, but this is quite easy. If it was a normal case class, we wouldn't have to do this. So this is going to be the first thing we're going to try to do. We're going to slightly modify this example. So I'm going to create a case class, person, name, of type string, and age of type int. Now I'm going to say get person, and this one should return a person. Okay, so let me try to recompile this. Doing the compile s, and now you see the big benefit here. So I try to modify the shared code. This is telling me that there is a problem with the code that I run on the client side. So let's try to fix this. Okay. So to not bother you too much, I'm just going to fast forward. Okay. So I'm going to do growl next and once more. So if you move back to the client side, we will now see that this has been changed. It's been updated, so it's now getting the user, and when it's completed, it's either going to say sorry, depending on the person that it's getting back. So let's imagine that we are back in Norway, and this is a place where we have access to alcohol. In Norway, we are very strict about this, so people under 18, they are not allowed to get anything. So here you see that this is really easy. This is type safe. If I try to recompile this, so the way we do this is using fastopt. Fastopt is just going to compile the front-end code, and it's going to optimize it in a fast way. For production use, you rather want to use the full optimization, so I have a small slide on the differences between these two a little bit later. So here you can see that this was successful. However, if I try to restart the server, we're going to see that the backend was not updated. So we see my server, object creation was impossible because this API is not respected. So you see here, this is still the old API, it's getting it from the server, and we want to return the get user call. So let me just fix this code. And now we're returning users, so either Jenny or Pierre, which is not old enough. Funny thing here. And this means that we can restart the server and everything should normally compile. And I can head to the front end. This always takes a little bit long. And we see welcome Jenny. Please enjoy. Okay. So let me get back to this. So this is a little bit big now. So to just compile the JavaScript, you want to get a faster turnaround here. So just to compile the JavaScript, use this fastopt.js. And if you want to compile everything every single time and restart the server every single time, this does not make for a very fast turnaround and nice development experience. So you really want to use this fastopt.js instead of just compiling the whole project. You can also make this obviously happen every single time you change one of your source code files using this tilde in front, right? Like you're used to. There is also the full opt.js, which you should use when you're deploying your application. So this is creating optimized JavaScript. And if you're looking at the size of this, let's see now, you will see that the size of this presentation is about 1.1 megabytes for the fastopt. So every single time I recharge the browser, I will download 1.1 megabytes. However, for the client, the fully optimized one, there is only 260K. So this is reasonable, I think. Then, depending on how many libraries you're using, etc., then obviously this might change a little bit. So we have seen Typesafe RPC. We have seen that we can define using AutoWire, we can define an API on the shared part of the application, and then we implement this on the backend, and we can use it from the front end, and we'll get compiler errors whenever there are any changes on one or the other side. So this is really nice. I think this is one of the main benefits of this. We can also use shared code more generally. So we could, for instance, imagine that we want to do some validation. Maybe instead of just returning a user to the front end, we want users to be able to enter and register. So I have a second example on this. Yeah, we can add some colors as well. Yeah, let's just move forward. So here I added this add user that will allow me to validate, that will allow me to add a user to some kind of data store on the backend. So here we are still on the backend side. We have this call to validate person. We take in a name and an age, and then there's some simple validation, so it's returning an either from the standard library. So either it's left or it's a right, and the person is being added or not. So let's go and look at how this is implemented on the API side. So here we see that we are sharing this validation logic between the front end and the back end. Okay, so for the front end, it's a little bit complex because we want to return the field in which the user had an error. So we have two parts here, returning two eithers. Sorry, we're returning an either with two options inside of it, and potentially a person if it's successful. So if first we're doing the validation of the name. So if the size of the name is too small, then we return an error. If it doesn't start with a capital, then we also return an error, and we're just doing a toInt on the age. And this is what's returned. So we also add a call, the add user, to the API that we already created, returning an option of a person. Right. And now we can use this in the front end as well as in the back end. So here you see, I told you that there's a lot of mess when you just want to add some form elements with Bootstrap. So let's not focus too much on this. What I want you to focus on is the submit part. So here we are getting the elements. So we're being able to call the validate person with the element directly from the form. And if it's a right, we will do an RPC call adding the user. If it's a none, so if it's a failure, then we will just add these invalid classes to our HTML. So I can start this over again, and we should be able to now see this new fancy form. So you see here, I can add. So name should be at least 2 characters. Age should also be a digit. So we see that we can fix these. And now this is working. It's doing the round trip to the server. It's validating. And in addition to this, it's also validating on the backend, because this is something you have to do, right? People have been telling you this before. You have to do validation both on the front end and on the backend. Because we cannot trust the client. So let's just imagine that we are the client and we modify this a little bit. So we do the validate. Instead of calling with the person that we have here, we can now try person with too few letters and some invalidate. So if I'm doing a fast opt of this one, and I type in a correct thing here, so I'm passing the first validation think this was not updated yet. You will see that something went wrong. So since I here tried to pass in an invalid thing and we're running the same validation logic on the front end and on the back end, this is correctly failing on the back end when I try to put in some bogus data. Okay, so this is another nice use case. A third nice use case of this code sharing is for sharing visual elements. So your UI between the two. This way you can do progressive web applications. So I know people are not doing this too much anymore, but there are still people out there that don't like to load all your JavaScript, and in this case being able to share the UI between the front end and the back end can also be nice, so that you can have better performance if people have JavaScript enabled. However, you always have a fallback to the original thing, and you can make this more easy if you are able to share the code between front end and back end. Any questions so far? Okay, let me continue. So we also seen that we can write this HTML using CSS and Scala tags. So here, for instance, we are creating a form. So we see here we have h1 elements, so we can add some strings, we can add some coloring to these h1 HTML elements. We have input fields, we have divs, we can specify classes for them, labels, etc., etc. So that's what I wanted to say. Okay, we can also play with canvas. So let me move to my next example. So here we're drawing some forms on the canvas in the browser. So we see that we do the begin path, we specify a couple of points that we want to go through, so we want to draw a rectangle. We have this case class, which is a point here, so it allows us to describe this in an easier way. And we can then draw these rectangles, passing it in a point and a width and a height. So we can draw it pretty much anywhere on the screen by passing in the start point. Okay, so let's have a look at what this looks like. So there's no server component here, so I can just do the fast opt. Okay, which will reduce the round trip a little bit. Let's go back, and here we see my first rectangle that is drawn on the screen. So we want to extend this a little bit, so I can create a couple of new shapes. So I have triangles, I have circles as well, and I'm able to draw them on any kind of place on the map. Let's try to compile this and see what it makes for. There you see, we got some random shapes created on random places on the screen. Okay, this is not too interesting in itself. So what if we could add some user input to this? Let's see. So here I added a new input field where we can enter some text, and then when we hit the enter button, we will parse the input of this text. So how are we going to parse it? Well, we're going to use this parser. So this one is able to detect these different shapes, and it will allow us to draw the shapes that has been typed in on the screen. Okay, so let's see. Sorry. I'm going to fast optimize this again. And waiting. There you see. It's coming. So I can now write, and I can add a random color to this shape here. So you see that these are drawn on random places on the screen, and we can change the shapes of this. Circle takes only one, and see the color here is not, the parse is not 100%, because if I add 2 spaces it always gets the same color, so I should probably fix that. Anyway, my next idea would be to integrate this with some user input. And obviously one way it's to use Twitter. Oh. Sorry. I'm going to recompile this, and this is using the Scala Twitter library. Hopefully there will be some tweets about Scala Days. Let's see. Yes. Okay. So things are turning up. Oh. I don't know what this is about. Okay, there's some bitcoins and stuff as well. Yeah. I think I might have changed something here. So anyway, Scala Days didn't have enough info when I was playing with this, and I did some errors in my git commit. So anyway, we're going to fix this. And the idea is that instead of having just random tweets, we are now going to try to parse these tweets, and we're going to try to draw some things on the screen depending on what kind of tweets you're sending in. So I will need some help here from you. So how is this working? I'm forgetting a little bit. It's always difficult to keep aligned on when you're doing this kind of presentations. Anyway, so what we're using is server-side events, server-sent events. So these events, they're being sent, and whenever there is, so we're connecting to this event source that has been defined on the backend. And whenever there is a new event, we are going to pass this to the parser that we just defined. So, source on message, we get a message event. What are we going to do with this message event? Unless the data is empty, we are going to append it to the string. And we're going to parse the input, and this parser is also, it's not very pure functional programming, so the parser is also drawing things on the screen, okay? But, well, for this example, I guess it's okay. So, I also have to check whether maybe some other changes have tweet source, Scala Days, yeah, Scala Zurich. So let's change this to Scala Days. So the idea now is that you can actually send a tweet, you can add some rectangles, etc. to this tweet, and hopefully we will be able to parse this info, and we should be able to draw some stuff on the screen. Okay, so let me just recompile the front end and the back end, so that we don't get the Scala Zurich tweets. I guess there are not a lot of Scala Zurich things happening at the moment, but anyway. I wonder if we should also add a small space here. Let's see. Yeah, let's try this. And let's fast optimize the new version. So this is all done on the front end, this part, and then we have just the tweets coming in from the back end. Okay, is anyone tweeting? Okay, it might take some time before it shows up. Okay, so what we need something looking like this. We need Scala Days, And then we need, for instance, rectangle, 23, 200, and some color. And rand will give you a random color. Wow. So I'm very curious, who is going to be the first one who gets this? Who is going to be able to draw something on the screen? Okay, no parents, no parents. Yes! Who was that? Who was that? Oh, big one! Awesome. So this was pretty much what I had to show you. I think I have a couple of slides more, but this is like the summum. Everything will just go downwards from here, unfortunately. So yeah, so check out the one. I have a list of frameworks that you might be interested in, because I mean, the reason why I want to do this presentation is because I want you to use Scala.js as much as possible, and I think it's a quite good tool. Maybe not for very like front-end facing with millions of customers kind of things, because the binaries are a little bit big, but for like internal applications, if you have Scala developers, don't force them to do a lot of JavaScript stuff. Instead, use Scala.js because it's quite awesome. It's a very good technology. There's also a lot of specific Scala.js frameworks out there. There's Udash, there is Outwatch. With Outwatch, you can also choose whether you want to code your front end in Scala.js or in PureScript. So if you're a little bit tempted to do some Haskell coding, then Outwatch might be the thing. I've been using Diode to make my front end a little bit more functional here, and not to have too much global state hanging around. We're still waiting for Susaku, but hopefully it's coming. I've been using Scala tags. There's also binding for other frameworks that is more commonly used in the enterprise world, like React and Angular. So these might also be useful. There's also bindings.scala. So let's go through some of the benefits of using this technology. You got to do functional programming, not only functional programming, but also type-safe functional programming on the front end. In addition, you got the Typesafe RPC, which is really awesome. So you don't have to think about serialization, deserialization, bugs when you're mixing these, etc. Going forward, refactoring front end, back end, it's really piece of cake. You got the famous Scala tooling, so amazing editors, SBT. No. You got to work with Scala, so this is also nice. So you got to avoid some of the quirks from JavaScript, and safe refactorings. And as I said, code sharing, so you can have the same code running in the front end and in the back end. Some challenges. Turnaround is a little bit slow, especially when you're always compiling the whole thing. So try to optimize your workflow so that you only use the full opt SPT as much as possible. And then, secondly, maybe this might be the most challenging part, finding front-end Scala developers. I don't know a lot of them, but I kind of like doing these kind of quirks in Scala. So anyway, any questions? Yeah, I want to show this one as well.
First of all, thank you very much. So I come up with a mic to anyone who has questions.
I would like to know, I know that AutoWire is working with Ajax Call.
Yeah.
And how would you do to do the same with WebSocket?
Aha, yes. Yeah, this is something I've been looking into for a while as well. So this is one of the missing parts, I think. Unless someone has some more information. Yes?
Actually, we're from the company which is behind the Udash framework.
Yes. So.
The first on the list. We are using the mic because people are back. Oh, sorry. Sure. Okay, so I'm from the company that develops the U- framework, and as for the RPC, we have it fully functioning on the WebSockets
Yes.
with pluggable implementations to come. If you use any specific techniques for the backend or something like that. Right now it's atmosphere based, so any backend goes actually. But it's done on the WebSockets. We will also support things such as observables and other reactive methods of obtaining data.
Small applause for this gentleman here.
Thank you. And there's another question I'm coming up. Can you
Yeah,
please?
so check out Udash.
What about writing single-page applications? Is that as easy as in doing it in JavaScript or TypeScript, or is this a problem? So because this, as far as I saw, is meant for the communication between backend and front end, and still an application where the server is sending the HTML to the client. Yeah, but in single-page applications, the architecture is a bit different. That works as well.
Yeah, so I've been focusing on this, how to say it, the full stack part, so communicating between a front end and a back end, because often you will need this. And I find this one of the most attractive parts of Scala JS and the Scala combination. So that's why I'm focusing this. But as you can see, the Scala JS here, this presentation is a single page application. So it's doing some calls to the backend, but it's a single page application, and this works very well. It's I would say it's better than the alternatives that you mentioned, because you got to code in Scala, but we can always have discussions about that.
Hi.
Hi.
First of all, thanks for the nice talk. It was really nice to see how somebody else presents the stuff. So we are using a quite similar setup in our project. And one point which is up for discussion currently for us is the debugging support. So do you already have some experience with that?
No, I mean, you have source maps, right? Which kind of helps you a little bit. Okay, so as you can see, I'm a Emacs guy, so but in IntelliJ Ultimate, this works with Udash only or with anything? With all Scala JS. It's great to have the people that are more familiar with this than me here.
This is the audience participation track.
Yeah.
I was wondering, do you have any experience in implementing this in a company?
Yes, so I'm not sure if I'm allowed to say this, but I do try to implement this in a company, but I just have to make sure that the boss is not here. Alexei, are you? No? Okay. So yes, I'm doing this in the company, a little bit out of the radar, but still it works quite well. Yeah. Don't tell anyone. Could you cut the video? No. There are sometimes big fears about adopting these new technologies, and people, I think, has been a little bit burnt by GWT, the Google Web Toolkit, and similar. But I mean, it's working very well, and I really think it should be given fair opportunities.
Hi. I noticed that you use a synchronous interface to communicate the front end and the back end here. Is this because a limitation of AutoWire or a limitation of Scala JS, or it was just?
I mean, this is a limitation of AutoWire, and if you use Udash, you probably are better off, right? Yes. So it's not a limitation with Scala JS.
We hear that this WebAssembly technology is coming to the browsers. You think that is something where Scala will target, or do you think it will remain with this Scala JS, or both, or like? That's an interesting question, I think.
Yes. Yeah, I don't have a opinion ID about that. But if anyone else wants to,
And come with the mic.
Anyway, I asked that same question to the developer of Scala Days a little more over a year ago, and then he was saying no, because WebAssembly in some way is not compatible with how Scala works.
Okay.
But that was 1.5 years ago.
yeah. Sebastian has been working miracles before, so maybe.